All right, so next we will take a look at another example using virtual functions. This is a bigger example. Best to demonstrate the use of virtual functions is code in the book, and this is the sale class and the discount sale class, those two pair, that one pair of classes. Okay, so the idea is that you have some kind of record-keeping program for an automotive parts store. You want to track sales. You don't know all the sales yet. First, you only allow regular retail sales, and later we allow discount sales, mail orders, stuff like that. So we start out with a basic sale class, and then later we go on to other classes, actually just one other class that we'll look at. Okay, so in this auto parts tracking program, the program must compute the daily gross sales and calculate the largest and the smallest sales of the day and perhaps some kind of average sale for the day. All of this information comes from individual bills, but the functions for computing the bills will be sort of added later when the different types of sales are added. So the function for computing a bill will be virtual. That's the key. So that's where the virtual comes in. Okay, so here's a look at the sale class. Basic class with public constructor, actually an overloaded public constructor with a price, a getter method for a double data member, we can guess, and sure enough here it is. And then a virtual billing. So remember, I'm just going to go back one slide. We want to be able to compute the bills, compute all this information about the individual bills, and so to compute this bill we use a bill function which we will make virtual. And then there's a savings method that doesn't really as you can see from the const here, it doesn't change this data member, it just figures out some savings. Okay, so simple basic class. Now let's take a look at the savings function and the less than operator. We probably want to also have a greater than operator, but we're not going to look at the greater than. Right now we'll just look at, keep it simple, just look at the less than operator. Okay, so here is the savings member function. It takes as input some other sale object and just figures out the difference between what the bill function returns for this as opposed to the other. So basically this minus other, whatever bill returns, is what this whole function savings will return. Okay, similarly, the operator less than returns a boolean, true or false. If true, if the first object returns a bill value that is less than the bill value returned for the second sale object. So it's just a basic compare functionality. This returns true or false. So this is a relational operator, has to return true or false. Doesn't. That's the common interpretation. So we want to stick with that. Okay, so notice that both of these use the member function bill. And remember, I'm scrolling back up. Remember that we are keeping it virtual. Okay, so the class sale represents sales of a single item with no added discounts or charges, and later on we'll change this to allow discounts. Notice we used the reserved word virtual in declaring the member function bill, and the impact is that later derived classes of sale can define their own version of this function bill. So that's the reason we're doing all of this. It's for polymorphism. Other member functions of the sale class will use the version based on the object of the derived class. Okay, so they won't automatically use the superclasses or the base classes version, that is sales version of the bill member function. Okay, so let's say Now that we've set up the sale class, everything's working, and now you want the auto parts store to have to be able to do discounts. So let's say now we set up a derived class or a subclass called discount sale, and here's how we set it up. You say class discount sale. Remember, we almost always use public inheritance. From now on, I think that's pretty much all we're going to do is public inheritance. And we say that it inherits publicly from the sale class, which we just defined earlier. So we have a new constructor. Remember, you don't inherit the constructor, although you can access it. You don't inherit the constructor of the base class. You have a new overloaded constructor with two parameters, two arguments, that is the price and the discount. Oops, this should be one word. This won't compile if you have two words. Okay. And then you also have in addition to the get sale, I'm just scrolling up, get price that you get from the sale class, and since it's public, you can use it in the derived class. In addition to that, you also have a getter method for the discount. So here's the discount data member. The price data member is in the superclass or the base class. You also have a setter for the same data member. And then here you see that you're overriding the virtual member function bill from the base class. So let me just scroll up again. Here is our virtual double bill, which is a const. That is, it doesn't change any of the data members in this class. All it does is compute something and returns a double. Similarly, here you have this double. You don't have to put virtual here. In this case, since the superclass has virtual, you don't have to. You can, I believe you can put it here and it won't make a difference. It's implicitly there. Okay, so now let's take a look at the implementation of the discount sale bill member function. That is the member function bill for the discount sale class. What it'll do is it'll compute out a fraction, which is the discount data member. Let me scroll up. Here's the discount data member divided by 100. So if you have a discount of 10%, that's the fraction will be 0.1 and so on. And so that you return the actual price, which is 1 minus the fraction times the price. Okay, simple percent discount. Okay, so the virtual qualifier does not go into the actual function definition. That is, you don't put the virtual here. It's automatically virtual since it's virtual in the base class. The declaration, that is a .h file, and that's the interface file, is not required to have the virtual keyword either, but usually it does. So it's good practice to put it in. It won't make a difference because that is, I'm talking about this thing, this bill member function. Since the superclass, that is the sale class, has bill as a virtual member function, it's automatically there, but it is a good idea to put it in just to make it clear. Explicitly put in virtual, even though it's not done here. Okay. All right, so that is how you set up a simple virtual class and you override it in a derived class. So basic look at a virtual member function. So now let's take a look at the savings member function and the less than relational operator. That's our overloaded relational operator less than for these two classes. So the discount sale member function bill is implemented differently than the sales member function bill. That is, it has something to compute discounts. The member function savings and less than, we will use this definition of bill for all objects of discount sale class. So instead of defaulting to the version defined in the base class, that is sale, we will use for all objects of type discount sale, we will use the current definition. So this definition of bill will be what's used for all objects of type discount sale. Okay, so the nice thing about this is recall that the class sale was written long before the derived class discount sale was written. So let's say we had the auto store up and running and you're computing out sales, computing out bills for years. Then they came up with this radical new idea of providing discounts. And so the member savings and things like, so the savings member data, member function and the less than overloaded operator, this will compile even before we had an idea of a discount sale class. So even though we didn't know about a discount sale class, the sale class will work, and yet, I guess in addition, in a call like this, let's say you have discount sale objects D1 and D2, you say D1.savings D2. Even though we don't have this savings member function defined in discount sale, we're using the member function of the sale class, which was written years ago. This call which calls bill knows to use the definition of bill from the discount sale class. That's a truly powerful thing, is that late binding gives you this. Even though you write the savings method, let me scroll back up for emphasis. You let's say set up a savings, which is, all right. It's not actually specified here, but it is in the, we'll take a look at it right in the code in just a second. The savings member function was written before we knew that, before we even thought that there might be a discount sale class. But still, it works correctly. That's really powerful. Okay, so let's take a look at this. We have the code here. Here is a simple use of the less than relational operator. Okay, and a use of the savings member function. So let's take a look at the sale class first. So we didn't have it in the notes, in the slides just now, but there is a savings member function in the sale class. Okay, let's take a look at what this does. The savings member function is pretty simple. Just returns the bill, whatever bill returns in the current, for the current object, and from that subtract whatever bill returns for the second, or the parameter. So this is set up in the sale class without really even knowing about what classes are going to be set up later, but it still works. It'll work for discount objects as well. So that's the key to, that's the nice thing about this, is that you have this simple instance of the sale class that works, but also once everything is set up, the discount object will also work. So you pass in the discount object here, and you're comparing a sale class with a discount sale class, comparing the savings, and try this for yourself. You'll find that it will work. A simple sale is $10 with a discount of 10% for $11 object. That will be less than $10, right? Because 10% of 11 is 1.1, and so it'll end up being less than $10. Okay, so try this example out. Once you try it out, I think it'll all make sense.